Hey there, algebra. Good morning. So the do now maybe is a little bit more challenging than I'd originally envisioned. So I think we'll just go ahead and we'll do this one. You can watch. I'll explain our way through this. So for each of the two following situations, we're going to write two inequalities to describe the situation. Right? Each every inequality is going to have an x in it. We're going to use x to represent the age. So here's situation number one. Think about the possible ages of teenagers. We're going to write two different inequalities to describe the lower limit, that's one, and the upper limit, that's the other, of what ages are considered teenagers. So start with the youngest age. So the youngest age, we got the x already there. We got our two answer boxes. We'll need to fill one of those in with an inequality symbol and the other with a number that is like the lower limit of being a teenager. So you start being a teenager at the age of 13. And so the x, your age, in order to be a teenager, would need to be 13 or more, right? So x is greater than or equal to 13. For the oldest age, there are some different ideas that we have about what actually it means to be a teenager. So one option is to say, well, being a teenager means your age should have teen as part of the word. So 13, 14, 15, all the way up to 19, right? And so we'd say, all right, maybe we'd say that your age needs to be less than or equal to 19, which is a good idea, except this actually doesn't include everyone who is in the 19 age year, right? Because if you're 19 and a half, that actually is a bigger number than 19. And so if we say x is less than or equal to 19, a 19 and a half year old, for example, is not going to be included. And that's not actually what we want. So I'm going to get rid of that symbol and that number. And we're going to change this instead to less than 20 because we want to include everyone who's 19 years old from 19 years exactly, it's your birthday, all the way up to 19 years, 11 months, and 30 days, right? Okay, so x is less than 20. The second idea that people have about what it means to be a teenager is that once you're 18, you're considered an adult. And at that point, not actually a teenager. And so sometimes we use teenage to describe, like, that age up until adulthood. And so in that case, we would want to say that x is less than 18. And it's totally valid description of what it means to be a teenager also. But with the same kind of description into it, we still want to include everyone who is 17 years old from it's your 17th birthday all the way up to the day before your 18th birthday. So it's going to have to be x is less than 18. All right, second situation, same directions, but let's look at movie prices. So movie theaters often offer discounts. In this case, we're going to say they offer discounted prices for people older than 60. And movie theaters also offer discounted prices for people under 12. So the young folks, it says here, people under 12. So that would mean not 12. It seems like it is saying that you have to be under 12, not 12, under. So x would need to be less than 12. So on your 12th birthday, you would no longer qualify for this discount. Anything less than 12 will work. And for the old folks, it says people older than 60, which means not 60 years old. You need to actually be older than 60. And so you could, I guess, if we keep with a consistent school of thought, like we said for problem number one, if you have to be older than 60, it's not just your 60th birthday that's not included. It'd actually need to be 61 years old is where it starts, not 60 years and 1 day. Right? So we're not going to say x is greater than 60. We'll actually need to say x is greater than or equal to 61. So that's the only way we can get the entire year of when you're 60, not part of this answer. All right, so here's what we're looking at today: compound inequalities. Our learning target you'll be able to write and graph a compound inequality. So obviously we're going to learn what is a compound inequality, but out of those 3 tasks that we're focusing on here in our study of inequalities, writing, graphing, and solving, we're only going to look at those first 2 today, writing and graphing. We'll see solving next time. So what is a compound inequality? Why would we use one? Well, so in the world out there, and there are many situations that have multiple requirements, like what we just saw with that do now. Sometimes a situation has a minimum and a maximum value, like when we were describing the ages of teenagers. And whichever number we decide is the end of being a teenager, that's not the point here. But you need to be at least 13 and at most 19 or 17 if we want to say that. But there's a minimum and there's a maximum, and you have to be between those 2 ages, right? Second bullet point, sometimes a situation has mutually exclusive restrictions. Mutually exclusive means if you are in this group, then you're automatically excluded from being part of this other group. You can't do both. It's either one or the other. So the discounts apply to either very young folks who are less than 12 or older folks who are over 60. Well, if you're in the under 12 category, that like automatically disqualifies you from being part of the old folks category. Like that's not possible, right? So mutually exclusive means if you're in this group, you can't be in that group too. It's one or the other. So these are the types of situations that we use compound inequalities to describe, where there are multiple requirements. So in order to get a compound inequality, what happens is we use words, actually. So our number sentences for compound inequalities are going to be made up of numbers, inequality symbols, and also words. So the 2 words that you see them highlighted here, the word and the word or. So and refers to a situation where both statements must be true. So we'll have 2 inequalities. We're going to combine them with the word and. That's like the situation we were describing the ages of teenagers. You got to be 13 years or older, and at the same time, 19 years or younger. Both of those have to be true. If we just said you got to be 13 or older, well, then like a 38-year-old would still be a teenager. That's not true, right? So you have to be at least this much and older, but this much and younger. They both have to happen at the same time. The green one, or either one or the other is true. So that's like the discounted movie tickets. Either you're less than 12 or else you're older than 60. You can't do both. That's not physically possible. So here's what it looks like. Let's just look at one part at a time. So in a number sentence, that whole thing makes up one number sentence. X is less than or equal to -3, or X is greater than 2. That's not offering you a choice. This is not an or for this student, like, oh, I do this one or do that one. The whole thing is a number sentence. The word or is part of the number sentence, and it's saying, here's what needs to happen in order for this number sentence to be true. Either the x has to be less than or equal to -3, or else the x has to be greater than 2, right? Which means either x is going to be really small, it's going to be less than -3, or it's going to be bigger than 2. It can't be in between them, right? And that's an important thing for us to remember, because when we graph these, you're going to have 2 dots on your number line, one at -3 and another one at 2, and you're going to shade outside of those 2 dots. Right? The middle part, that's where x can't be. It's got to be either less than -3 or greater than 2. So you don't shade the middle, only going to shade the outside. All right, we still have to pay attention to what type of dot goes on which number. So the dot at -3, since that symbol has got the or equal to, it's going to be a closed dot. And at x is greater than 2, since there's no equal to, that's going to be an open dot. But we've got 2 dots on the number line, and then we shade outside of them. Okay, with and, let's just go one piece at a time here. Again, the word and is part of the number sentence. That whole thing is part of the number sentence. X is greater than 1 and x is less than or equal to 5. That means both of these things have to be true. X has to be bigger than 1, and at the same time, x has to be less than 5. Which means, if we said it another way, x has to be between 1 and 5. And the 1 is not included because it says x is greater than 1, not greater than or equal to. But the 5 is included because it says 5 is less, x is less than or equal to 5. So we're going to again have 2 dots on our number line, and this time we're going to shade between the 2 dots. So start and the stop dot, and you're going to shade the middle part because that's where x needs to be in order to satisfy this number sentence. Okay, so before we get to the graph, let me just say there are 2 ways to write a number sentence for an and compound inequality. So we've seen the first one. It actually uses the word and, the first bullet point up there. And here is the second way we can do this. It's going to have 2 inequality symbols in the same number sentence with the x or whatever variable in the middle, right? So it's the same description that we just saw. X must be between 1 and 5. That's like the interpretation of what the original number sentence means. And that's actually the way we can write the number sentence as an alternative way, right? You put the x in between the 1 and the 5. You got your 2 inequality symbols. And those 2 inequality symbols are always, always, always going to open the same direction as each other. You don't have like one opening this way and one opening this way where they're both trying to chomp on the x, or the other way around. They always have their mouths facing the right. This is the only way it ever happens, right? So the number line looks exactly like what this blue number sentence looks like. You got a dot on the 1 and a dot on the 5. And just like in the number sentence, x is between those 2 numbers. That's what you're shading. You're shading between those 2 numbers. We've got different kinds of dots because those 2 symbols have one of them is greater than 1, but not the equals to there. So it's going to be an open dot on the 1. And with the 5, x is less than or equal to 5. Or equal to tells us a closed dot. So on the 5, we've got a closed dot. All right, let's do another example here. The inequality is already written. We're just graphing here. So x is less than or equal to -2, or x is greater than 3. So it's an or inequality. Let's get some color coding in here so we can tell what is what. All right, so let's look at the green part first. X is less than or equal to -2. The symbol there has the or equal to, so it's going to be a closed dot on the -2. And we can actually graph this kind of as 2 halves. So x is less than or equal to -2 means from that -2, I'm going to shade towards the left. The blue part, x is greater than 3, greater than, there's no or equals. So there's going to be an open dot on the 3. And then x is greater than 3 means I'm going to shade towards the right. Double check to make sure this actually looks like what an or should look like, which should have 2 dots, and I shade on the outside of those dots. That's what I've got. Next example, graph x is less than or equal to 1 and x is greater than 3. So this is an and. Get some colors on here. So let's do the green part first. X is less than or equal to 1. Or equal to means I could use a closed dot on the 1. With ands, I would recommend not shading yet. I think it's always a better idea to get both dots on here first. -3. X is greater than -3, so that's going to go towards the right. So an and should have 2 dots where I shade in between them. 2 dots, shade the inside. And only going to shade just between the 2 dots. You don't like start at the blue one and go like all the way over to the right end of the graph and start at the green one all the way to the left end of the graph. We're only going to shade the part where those 2 like shaded regions overlap. So the only place I'm actually shading is just in between those 2 dots, because and that's what and looks like. Hey, so let's look at an example or two here. So camera cars. A crane sits on top of a camera car. It's got the camera at the end of that big boom arm. The camera faces out front. Crane's maximum height and minimum height above the ground are shown in the illustration. So minimum of 4 feet all the way up to a maximum of 18 feet. The directions ask us to write and graph a compound inequality that describes the possible heights of the crane. So before we do anything else, let's think about, would this be a between kind of situation, or an outside of two requirements kind of situation. Um, so the camera could go anywhere between 4 feet up to 18 feet, right? We can move that's the whole thing about having an adjustable camera. You can do anything inside of that range. So if you imagine our number line going up and down, we'd want to have one boundary at the 4 feet, one boundary at the 18 feet, and everything in between those two numbers is what's possible. So if we're going to write an inequality in order to get a between, we're going to use the word and. So we got two options here. We could say x greater than or equal to 4 and x is less than or equal to, what was the other one? 18. Option number 2 is, instead of using the word and, we could use the number sentence where we put two inequality symbols on either side of that x. The littler one goes on the left side, the bigger one goes on the right side.